Okay, so this is 12.2b in intermediate algebra, continuing on with ellipses and hyperbolas. Alright, so this, what I have up here, is an equation for an ellipse. Alright, so the book doesn't go into this, and I should have just ignored the book, done it my own way earlier, and written this equation like this. Oops. Let's do it this way. Okay, so on the other example, let's go ahead and get rid of this 9. Remember, this is an a squared, and this is a b squared. So it's just a letter representing a number. Alright, so notice what we've got up here is we've got an equation that's very similar to this one. This equation is the equation of an ellipse with the center point at 0, 0 at the origin, because H, K are two letters that you use to determine the center point of an ellipse on a graph. So H is the X, K is the Y. Okay? So when the center point of the ellipse is on the origin, this H here is 0, and this K here is 0. So when you really write the equation, instead of writing x minus 0, you just wrote x squared over a squared. And then this was y minus 0, so you don't have to write the 0. And you get an equation like that, which is what we learned up here when the center point is on 0, 0. The h is 0, the k is 0. But if we have a center point that's someplace else, let's say that it's over here, then this number here and this number here are not going to be zeros. So all that to say is, when we have an equation, let's go ahead and write it like this. That's a K. And that is, whoops, come on pen, that is squared. Alright, so again, when h and k are 0, then our origin is, or our center of the ellipse is at 0, 0. When our h and k are different letters, that tells us that our center point is somewhere else. Okay, so for instance, if I had x minus 4 quantity squared over 9 plus y minus 1 quantity squared. Okay, and I've got an equation like that. That's going to put my origin, or my center of my ellipse, at whatever makes this 0 and whatever makes this 0. So what makes x minus 4 0? Well, when x is 4, 4 minus 4 is 0. When y is 1, that makes 1 minus 1 0. So that is the center point of my ellipse. So 1, 2, 3, 4, and then 1. Right there is my center. Okay, then I look at this. Square root of that is 3. So I know I go over 1, 2, 3, and I go over 1, 2, 3. Okay, and then this is 2. So I go up and down 2. So I'm right here at 1, so I go up 2, and I go down 2. And I've got 4 points there. And I can draw a pretty ellipse that way. Okay, so again, the bottom numbers still represent square root of each of the bottom numbers, how far you go left or right from the center, how far you go up or down from the center. The number that makes this 0 is the x value, 1, 2, 3, 4, and whatever makes this 0 is how far you go up or down. So we go up 1, and that's the center. You do that first, then you take the square root of that, and you go that many over, square root of that, you go that many up, that many down. From the center, not from here, not from anywhere else, but from the center. So that's why you have to find the center first. Okay, this is example 3. Taking a long equation like this, and I'm going to make it look like this. Alright? So we did these with the circles, so we're going to continue doing these with the ellipses as well. So we're going to put all the x's together, and then the y's together, and then we'll put the 76 on the other side. So negative 76, because we have to subtract from both sides. So that took care of everything there. Okay, and then remember what we did when we solved these. These get a little bit tricky, but if you just follow along here, I think it'll start coming, or you'll at least see what I'm doing. Space. Space. Alright, so over here, for this third term, for the number that goes here, we're going to take half of that and square it. Okay, and we're going to circle that just so we remember it's there. Alright, and then we take half of that and square it and put it there. But one of the things that's a little bit different here with this one than this one is this does not have a number in front of its x squared, and this does. We want to take that away. So what we're going to do is we are going to do this in blue. We're going to factor out the 9, and what are we left here? 9 times 6. Okay, so now we just have this here. So we take half of that and square it. Okay? Alright, now again, this is where it continues to stay a little tricky, and that's why I'm asking you to really pay attention to what I'm doing here so that when you get it in your homework, you're following what's going on. Alright, so, and we've got it, nope, wrong color. 9. Okay, so remember what we did with circles. If we did something to one side, we also had to do it to the other. So we added a 4 to this side. We just added a 4, so we also have to add a 4 over here. Okay, now this is, again, this is where it gets a little tricky, and even kids in college algebra and calculus, they forget this. What did I add here? I added a 9, but I not only added a 9, I added this 9 times this, because this is going to be distributed, right? This isn't just y squared minus 6y plus 9. This is 9 times the quantity y squared minus 6y plus 9. So I need to say 9 times 9 is 81, and that's what I'm adding over on this side as well. So even though it looks like I only added a 9 there, I actually added a 9 times 9. So when you have a letter or a number in front of one of your letters squared like this, you factor the 9 out, and then you take half of that and square it, and then that number times that number is what you add. Okay, that's the only time you really do anything with these, is when you're trying to figure out what to add to it. Okay, so now that I've got you totally confused, square root of first term, square root of the second term, this sign right there, squared. Okay, that looks pretty good. Now I've got that 9 just tags along, minus square root of 9, and I square it all over. Oops, I'm not going to put it over anything yet. What am I thinking? Let's just leave it the way it is. And then that equals negative 76 plus 4 plus 81 is 9. Alright, so now I've got it written this way. What does this have to be? Well, according to my formula up here, it has to be equal to 1. So I'm going to divide that by 9, that by 9, and that by 9. So that gives me x plus 2 quantity squared over 9 plus, these cancel, but I'm going to put the 1 on the bottom anyway because I need to have it as a fraction, and 9 over 9 is 1. Okay, so there is my completed solution where all I did was change this original one right here into this one. Okay, now that I'm done with that, I can graph this. Okay, so let's graph this. What makes this 0? A negative 2. And what makes that 0? A 3. So that's my center point of my ellipse. So over 2, up 3. So my center's right there. Then I take the square root of that, which is 3, and I go left and right 3. 1, 2, 3. 1, 2, 3. Square root of 1 is 1. So I go up 1 and down 1. So my ellipse, try to make it look like that. Okay, well there's the two equations for a hyperbola. So remember, when the x is first, it's going to look like this. When the y is first, like here, it's going to look like that. Okay, so it just depends on how they give it to you, on what it's going to look like here. So let's go ahead and make my pen just a little bit bigger and see if we can draw this thing. Okay, so here is my equation. Okay, so let's go ahead and put everything the way it should be written. So 4. Okay, move the 20 over. Okay, and let's see what we've got here. So because we don't have any x's except this x squared, we can't really do a whole lot. So we're just going to kind of leave that alone. So, and then we're going to put a parenthesis on that. And we have y squared and minus 4y. So notice what I did is I put a parenthesis around here, which means I left the negative outside, which when I take a minus here, it's going to be minus this and minus this, and a negative give me my positive. So in order to get this positive back, I have to have a negative and a negative. So half of that squared, half of 4 is 2 squared. So because I added a 4 there, I have to subtract 4 there. And you're like, wait a minute, why are you subtracting a 4 when it's added? Well, this negative is not only on the y, not only on this, but it's also on this. So a negative of a positive 4 is a negative 4. So that means this is why it gets tricky. When you put the parentheses around there, then there's a negative out here. Everything in here changes, or this changes the sign. This will always be a plus, but instead of adding 4 here, you're subtracting it because of that negative. Alright, so let's go ahead and write this as 4x squared minus, and then we're going to go y minus 2, the quantity squared, equals 16. And we're going to divide both sides by 16. And this becomes x squared over 4 minus y minus 2 squared over 16 equals 1. Okay, so there's my formula. So I'll take this picture in the next video and we'll finish up in just a couple minutes.